Today we're going to do 6.1.4 flowcharts for congruence. Remember, you have to turn in your notes to get credit for today. Today there's going to be some stuff that you have to do on your own, as well as some stuff that we're going to do together that you have to have written on there. There's not many of you that are missing things from last week when I was gone, but there's a couple of you that are missing a couple little assignments here or there. So if you don't have those done, go ahead and try to get those done and turned in this week because they're going to help your grade a lot. I think everybody kind of got their 5.3 review and their Chapter 6 or Chapter 5 review done. There's just a couple people that haven't, so if you didn't get those done, get that turned in, because just those two assignments right there are 20 points alone. So here is the book. If you want to open your own book to look at it, go ahead. You guys might hear Mr. Moreland and Colt in the background. I apologize in advance. I'm obviously making this video at home right now. So this says, now that you have shortcuts for establishing triangle congruence, how can you organize information in a flowchart to show that triangles are congruent? Consider this question as you work today with your team. You're kind of working with me. You can work with a partner in class if you'd like. In problem 6-1, you determine that the triangles at the right are congruent, which triangle congruence theorem shows that these triangles are congruent. Make a flowchart showing your argument that these triangles are congruent, and how is a flowchart showing congruence different from a flowchart showing similarity? List every difference you can find. So, I'm going to help you work your way through this congruence chart, and then you are actually going to answer part C on your own. You have similarity charts in your notebook. If you need your old notebook to look back at from last semester to find your similarity charts, you can go ahead and get it out of the cabinet and look at that. But I want you to show every single difference between a congruence chart and a similarity chart. So we can see on this one that we're going to use side, side, side. So this side is congruent to this one. This side is congruent to this one, and this side is congruent to this one. So let's start with that first side first. So we can say AB over FD equals 1. Let's do the next one, which is BC over DE equals 1. We're just saying that their proportion is 1 because they're congruent, right? So their proportion has to be 1. The next one is AC over FE equals 1. So we have our three pieces, which is side, side, side. We can probably already go ahead and put side, side, side congruence down here for our justification. And then we have triangle ABC is congruent to triangle. A corresponds to F, B corresponds to D, and C corresponds to E. And that is all she wrote. That's the whole entire proof there. So it says, which triangle congruence theorem shows that these triangles are congruent? We're going to say side, side, side congruence. Make a flowchart showing your argument that these triangles are congruent. And then this last part is what you have to answer in your notebook. You and a partner can work on it together if you'd like. It says, how is a flowchart showing congruence different from a flowchart showing similarity? List every difference you can find. There's some pretty obvious ones, but also pay attention to this part. What's really specific about congruence when you're comparing sides? That's a big one that I want you guys to list. Okay, this is a really quick question that we're just going to kind of talk about together because it's actually kind of important. And it's not something I think you'd necessarily put 2 and 2 together with, but you can do this. So it says in Don's congruence chart for problem 29, one of the ovals said AB over FD equals 1. In Phil's flowchart, one of the ovals said AB equals FD. Discuss with your team whether these ovals are the same thing. Can equality statements like Phil's always be used in congruence flowcharts? I am answering this one for you guys because this is actually really, really important. And it's actually going to make this a lot easier. We start out with saying this notation. And the reason why is because with congruence, it's really important that your proportion for your sides is 1. Because if it's not, then they're not congruent. So we start out with that notation so that you really get that concept of knowing that their proportion is 1 and that's why they're congruent, not just similar. However, when you are making your flow chart, so for the last one you had AB over FD equals 1, you can say AB equals FD. And then let me go back to our chart. We said BC over DE equals 1, so we can say BC equals DE for our next bubble. Then we said AC over FE equals 1, so we can say AC equals FE. This actually is the same thing. The reason we don't start out with that is just because that concept of those being, their proportionality being 1 is actually really important. So then we could just make this exactly the same chart. So triangle ABC is congruent to triangle FDE. And you'd say side, side, side congruence. This is the same flow chart. That proportionality is just written a little bit differently. That actually means the same thing. You actually can write those that way. So if you guys want to start writing those that way for the sides, go for it. I actually think it's easier, and now that you guys know it, I probably will write them that way too. Okay, the next problem just says make a flow chart showing that these triangles below are congruent. I'm going to start you off on the right track. And we know that these are congruent because they're vertical angles. You also have these angles here, and you have these two sides are congruent. So I'm going to do a different proof that's pretty similar for you guys to give you an example before you do that other one on your own. You need to have both of these on your notes because I kind of want you to try one with me, but I want you to be able to do this on your own as well. Okay, so this problem 31, you're going to have to try it on your own, but we're going to do this one together first, which is actually harder than problem 31. So it says, given that C is the midpoint of BE, that means that these two are equal because that's the midpoint. That means that's the middle of that line. And that AB is parallel, that's what this little thing means, is parallel to DE. So we can actually denote that with these lines that say they're parallel, right? So if those are parallel, we know that this angle is congruent to this one. We also know that D and A are congruent. So I also have angle, angle, side. I just have them in different locations here. So I'm going to start out with my two angles that I have in blue. So I'm going to say the measure of angle A equals the measure of angle D. Remember, it's important that you have that little M in front because A isn't equal to D, but the measure of angle A is equal to the measure of angle D. The next one is the measure of angle, and if you started with A on the other one, you probably should start with B here. The measure of angle B equals the measure of angle E. It just is nice to make sure you have everything lining up in the same place. The next thing that we can write is BC equals EC. Now we have our arrows. And we can say triangle ABC is congruent to triangle D corresponds to A, E corresponds to B, and C corresponds to C. And then we say this is angle, angle, side, congruence. So I want you to go ahead and pause this video here now. You should have 3 bubbles written on your paper. You just need to fill in the bubbles now. You have the rest of the template. You have to fill this in to get full credit for your notes today though. So pause this video here, fill this in, work with a partner if you need to. We are going to go through this together and make sure that you have the right answers tomorrow, but I want you to try it on your own first. Just a reminder, these are the triangle congruence conditions or theorems. Either way you say that is fine. So if you don't have these written down already, you probably want these. These are the only 5 that work for congruence. There's others that work for similarity, but these are the only 5 that work for congruence. So if you don't have these written down already, please write them down. Just pause the video and write them. The next question says, in each diagram below, determine whether the triangles are congruent, similar but not congruent, or not similar. If they're not similar, they're obviously not congruent either. If you claim the triangles are similar or congruent, make a flowchart justifying your answer. So let's just go through these and decide what we should use first. So this first one, you actually have a set of parallel lines here. So these two are parallel lines. If those are parallel lines, we know that the alternate interior angles, so these are alternate interior angles, those are congruent to each other. They gave us that these are congruent, and we have a shared side here. So we actually have angle side congruence on this one as well. So this is going to be angle side congruence. I'm going to erase a little bit of stuff on here. We know these are congruent. Whoa, I drew the wrong one. Okay, so that's what you're going to need for that one. If you look at the next one, we have vertical angles here. So this angle is congruent to this angle. They also give us another angle that's congruent to each other, so these 50-degree angles. But we really don't have more than that. We know that these other angles are congruent if the other two are, just because of the triangle angle sum theorem. However, we have a 4 and a 5 here. Because of that, these can't be congruent. But angle is a similarity theorem, so we can say that these are similar, and we're going to say angle similarity. So we've got 2 flowcharts we need to make so far. And the next one, we're going to look and see if we can use hypotenuse leg. We don't have the hypotenuse on either of these though, and this side, so if we do 3/2, it is not proportional to 6/3, so we're going to say these are already not similar. The next one, we actually do have hypotenuse leg on this one, and I'm going to show you why. We have the hypotenuse, obviously. But then we can use the Pythagorean theorem to find these other ones. If you do 13 squared equals 5 squared, let's just name this b, plus b squared, you'd have 13 squared minus 5 squared equals b squared. I just subtracted this 5 squared from both sides. Then you'd have to take the square root of both sides. So you'd have the square root of 13 squared minus 5 squared equals b. If you go ahead and put that in your calculator, you're going to get that 12 equals b. So this up here is going to be 12. Well, if that one's 13, 12, 5, we know this one's going to be a 5. So 5, 12, 13 is actually a Pythagorean triple. These are similar, or they actually are congruent, because we have hypotenuse leg. So we're going to say hypotenuse leg congruence. Remember, you only need as many bubbles as you have letters in your similarity or congruence statement. So if you have hypotenuse leg, you just need to prove hypotenuse leg, right? And then we're going to have our conclusion bubble, and we're going to say hypotenuse leg congruence. So let's just go ahead and start with this one because we haven't really done one of these yet. So the first one is going to be MK equals QR. So there's our hypotenuse, then we just need one of those legs. You can either use the side that's a length of 12 or the side that's a length of 5. I'm just going to use the one that has the 5. So ML equals QP. So there's our hypotenuse leg. Now we just need our congruence statement. So triangle MLK is congruent to triangle QPR. Remember, these have to be in corresponding places. So M is in the same spot as Q on that triangle, right? L is in the same spot as P on that triangle. And K is in the same spot as R on that triangle. Them being in the same corresponding spots is actually really, really, really important. So make sure you guys have that. Okay, now instead of just completely doing A for you guys, I'm going to do the same thing that we did on the other problem. I put some triangles next to that one that are actually pretty similar to that proof you're going to have to do. This side is the same on both of those, obviously. So I'm going to do this one for you guys, and then you'll do problem A on your own, on your paper. So this must be on your notes to receive full credit. You need the flowchart. I'm not going to do that one for you, but I'll do the one next to it that's really similar so that you can see me do it, and then you're going to get some practice on your own. So this one is angle, side, similar, or congruence 2. So it's the same thing. It's just a little bit of a different triangle, so it just doesn't have the same letters. But this really is the same kind of proof. So I'm going to start out with saying the measure of angle C equals the measure of angle G. They show that to us on there. Then we have the measure. Ooh, I'm going to run out of room here. Hold on. Okay, I just scooted it over. The next part is I wrote the measure of angle F is equal to the measure of angle F. That's because these both are kind of right here at F. They don't have different names. So if you guys have those where they're both connecting at the same point, you would say the same thing. The last piece that we have is BF equals BF. And the reason why it's the same order is because if you notice, we have these two angles down here at the same place. On yours, they're at opposite places. So one of your bubbles is going to say AC equals CA to have corresponding pieces together. So make sure you pay attention to that. The last piece that we need is triangle BFC is congruent to triangle. Remember, we need corresponding parts. We're going to have B on the next one also. If we did F next, we're actually going to have F next on the other one. And then if we did C, we're going to have G. And this is angle, side, congruence. That last piece is really important, so make sure you remember that. Okay, we're going to do the same thing again for B. I'm going to pull up a triangle that's pretty similar to this. It's not connected, but it's a pretty similar proof. We'll do that together. You have to have that on your notes as well, so just like this one, you have to have this one on your notes with your flowchart to receive full credit. I really want you guys to get these. So we're doing some together, but you also have to try some of these on your own. If you don't get it right, that's okay. You at least have to attempt it. It should be pretty easy to get these right, though, after we did one that's pretty similar right before that. Okay, so you can see the angles marked on mine. We're also going to use angle, similarity on here. You guys should be pretty good at these already because we did similarity flow charts at the beginning of this year. You guys all did pretty good on them on your test. So just in case, here's an example first. You have to write this down on your notes to receive full credit on your notes. So we have the measure. This is really the hardest part, making sure you have the measure. So the measure of angle A equals the measure of angle P. That's really the hardest part, is making sure you put measure in the front. The rest is pretty easy. Then we have the measure of angle B equals the measure of angle Q. The last thing we need is the congruent, well, not really the last thing, but we need the congruence statement. So if I say triangle ABC, not congruence, but similarity statement, sorry, is similar to triangle. If we put A first, P has to go next. If we put B next, Q has to go next. Then if we have C last, R has to be last. We need our arrows. Remember, that's super important. There were some people on their test that missed points just for not putting arrows. That's really important because if I put the arrows this other direction, this means something completely different. We can't do that. So the arrows are actually really important. Otherwise, these are just three bubbles that don't really mean anything. And then we have to say angle, similarity. So go ahead and use that similarity chart to try to do the one for problem B. That similarity chart has to be on your notes to receive full credit. Okay, this is the last problem that you guys are going to have for your notes before you can turn those in. And this is actually a problem that you're going to do on your own on your notes. So it says, suppose you are working on a problem involving the two triangles, triangle UVW and XYZ, and you know that UVW is congruent to triangle XYZ. Can you conclude, or what can you conclude about the sides and angles of the triangles? Write down every equation involving the side lengths or angle measures that must be true. So you should have kind of three angle statements that are equal to each other. Whoops, equals the measure of angle equals the measure of angle. You have to say which angles are equal to each other. You also should have three side lengths that are equal to each other. So these are going to be sides. These are going to be angles. So you should have that on your paper. I also want one other thing for you guys to draw on here. I want you to draw the diagram. That would make this statement true, and label all congruences. So you should have angles and sides. Remember, if I have two sides that are congruent, the first set is going to have one line, the second set's going to have two lines, the third set's going to have three lines. If I have angles that are congruent, the first one's just going to look like this, the second set is going to look like this, the third set is going to look like this. You just add another line each time. So make sure that's on your notes. Your homework is 34, 35, 36, 38, and problem 40. I'm going to pull up this first problem and we're going to go through a little bit of it together. These are problems that are actually really important to use your flashcards on. So this says, use your theorems about parallel lines and angles formed with a third line to find the measures of the labeled angles below. Show each step you you use to be sure, and be sure to justify each one with an angle theorem from your angle relationships toolkit. Just use your flashcards. Be sure to write your reasoning in the order that you find the angles. So let's just go ahead and do B together. We know that this angle given and F are supplementary angles, which means that they add up to 180 degrees, right? So if we do 180 minus 82, you get 98. So this is 98 degrees. And we know that that angle and E are alternate interior angles. So you should have on here supplementary. The next one is alternate interior angles. Alternate interior angles are congruent. These equal 180 degrees, right? This is congruent. So we know this is 98 degrees. Then that is a vertical angle with D. So you'd have vertical angle. This is angles. Alternate interior angles. This is supplementary angles. Vertical angles are congruent. So we know this is also 98 degrees. So you just had to solve for one of those to get all of them. All of these proofs, you guys, are pretty similar, actually, or not proofs, but all of the ways to find these angles are pretty similar, actually. So just going through that one should help you guys a lot to get A and C as well. Okay, the next one says, for each pair of triangles below, decide if the pair is similar, congruent, or neither. Justify your conclusion using a flowchart. Assume that the diagrams are not drawn to scale. Redraw and label the diagrams as needed. I actually wanted to go through these with you guys because these are kind of tricky. This is actually going to be side, 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 not congruence, but similarity. Sorry. And the next one is actually going to be angle, angle, similarity. You will need these two vertical angles that are the same. You're obviously going to need your third angle on A as well. So you're going to have to use the Pythagorean theorem. You guys should know that this is a 3, 4, 5 triangle, right? So if that's actually true, the 6, 8, 10 also has a right angle, which means these are side, side, side similarity. So make sure you guys have your flowcharts. You should have 3 bubbles here, and then just your bottom one because you have side, 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 and say side, 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 side similarity. And here you should have your 2 bubbles, your conclusion, and you should say angle, angle, similarity. The next one says solve the system of equations below using any method. If possible, show all work and check your solution. If there is no solution, explain why not. On this first one, you guys, I would use substitution. That means, remember, this is why I had you guys do this last year where you put these boxes around here. All of these things are equal to each other, right? So we can plug 2x plus 8 in for y. So you do 3x plus 2 times 2x plus 8, because we said y equals that, equals negative 12. Just solve for x and then plug that x back into this first equation to solve for y. So use substitution. If you guys are having a really hard time with this substitution, look up on YouTube Patrick JMT substitution. That's actually a guy that does YouTube channels just for math, and he has some really, really good ones. So use Patrick, I think he might have a CK here. but Patrick, JMT, and then just whatever subject you need. So this one you would need substitution. So do Patrick, JMT, substitution if you're having a really, really, really hard time with that problem. Do that, and then also ask me about it when I get back, so that you can get some help on that. That video that he has might help you guys. I'll try to link it on here too when I put this video up. But if you're having a hard time with it, also ask me about it when I get back, because there might be questions I might be able to answer for you that you didn't get from that video. Okay, the next one, you can also search Patrick, JMT, and then do elimination. There's also a really good video for that one. So I'm going to start you off on this though, because this is a little bit different. So usually with elimination you'd subtract these things, but you don't have your x's and your y's lining up in the right place. So we kind of have to fix that first. So we're going to say negative 5y plus 2x equals 4. So I just rearranged that first equation, and then you have 5y minus 2x equals 10. I'm actually going to solve this with you, but if you're really confused on this, you probably should look at that video, because you're going to have to know how to do this. This is going to be on your Y-top, this is going to be on your ACT, this is probably going to be on your test at the end of this chapter, because this is probably going to be a checkpoint problem. So you're actually going to add these two equations. So you've got negative 5y plus 5y, that's 0. Negative 2x plus x, that's also 0. This would equal 14. We know that 0 cannot equal 14, so you would actually say this has no solution. Remember, that's a symbol for no solution. So I just did half of problem 36 for you. Okay, the next one is problem 38. It says solve the problem below using any method. Show all work. This is actually kind of tricky. If you go to your ebook, you can see this homework help tab. You might end up using that homework help tab on this question. There's multiple different ways to do this actually, and this is all just going to be what your preference of solving this is. So I'm going to start you out with just the way I would probably do this. So it says angle A of triangle ABC measures 5 degrees more than 3 times the measure of angle B. So in pre-algebra, I actually kind of teach the kids, read this backwards. So it says 3 times and then 5 more. So we know that A equals, we're going to do, whoops, angle A of, okay, so we're going to do 3 times B and then 5 more. So you kind of read this backwards. So it says the angle A of triangle ABC measures 5 degrees more, so the 5 degrees is last, than 3 times the measure of angle B. Angle C measures 20 degrees less than angle B, so you do B minus 20. Find the measures of angles A, B, and C. So you're going to have to kind of make your equations and try to solve for that. There's multiple ways to do this problem. If that's not a way that makes sense to you, go on your ebook and click that homework help tab. If that still doesn't make sense to you, make sure you ask questions about this when I get back tomorrow, because we're going to go through homework questions anyway, so you might as well ask about this one if you don't understand it. I'm going to do it a different way if you guys ask questions on it, so that you see a different way, because obviously this one didn't make sense if you're asking me questions about it. The last one that you have for homework says, given the diagram at the right, which statements below are not necessarily true? This is a multiple choice question, so I'm not really going to go through this with you, but make sure you use your note cards on this question. You should know things like T and U are vertical angles. Q and H are alternate interior angles. R and B are corresponding angles. R and D are same side interior angles. You should know those kind of things for this question. So go ahead and work on this homework if you guys still have some time left in class to do this. And then if you still have time after that, please work on any missing assignments that you have if you have any.